So a very good wrap-up of GDPR. Yes, it was in Italian, so I can understand it. 70% probably. So now I will be able to skip a few things in my talk and focus on the aspects around data science. So GDPR can be something very frightening. You can be very scared about GDPR. Probably you must be. Given the fines, 2%, 4%, it's like a bummer. However, what if we take it from the other angle and say, okay, so we have to do it, right? So we got to do that thing. So what can we leverage with what we have to produce for GDPR, right? As an entrepreneur, so by the way, but myself as an entrepreneur, I take a problem, I take a solution, I take another solution, I look at which one is going to be the best for my customers, right? There is the scarier thing is always a good point for business, but you have to satisfy so many things for GDPR that it's hard to find a good solution. So looking at GDPR from the angle of what kind of added value I can extract from GDPR is probably the best one for a startup like mine. So I'm Andy Petrella. So I started Kensu. Back then it was Della, a service company around data science, because my background is in math and computer science. And my buddy, co-founder, exhibitor over there is a physicist and a computer scientist as well. And we created Della, then Kensu, in order to try helping data scientists without data science tools. Because for us, there is no one, data science tools. You have many, and probably you will have to use many in order to achieve a goal. Why? Because you have many teams as well, anyways. And it's pretty obvious that the data comes into the company from one side, and it has to go across different steps before, being applied into the business layers, for instance. Okay, so we started with this agile data science toolkit, which is not a toolkit for data science per se, but it's just a wrapper around the different data science tools. Then you say, okay, it's hard to provide tools for data scientists, even if they are not data science tools, sorry. So we're going to focus on the thing that we have created back then is a catalog. So you have heard a lot of a catalog, I guess, right? So you know what is a catalog, right? Who knows what is a data catalog? Nobody knows what is a data catalog? Seriously? Just raise your hands, man. I mean, go ahead. Data catalog? I mean, Google is a data catalog, by the way, right? So it's just a kind of an indexer. You go there, you search for something, and then you will get a URL, a pointer, or whatsoever that points to the data. And when I was using data in geospatial, because my background is in geospatial, I had to create catalogs, because in geospatial, catalog is a native problem, because geospatial data are used by government all over the world in order to cooperate actions. So if they don't understand each other, if they cannot share data, they're all screwed. I mean, we are all screwed, by the way. So catalog is a native problem, and I said back then, I said, it's cool to have information about the data, but what if we have a catalog that doesn't really care about data, but cares about what the people are doing with the data instead? So that's what I'm going to talk today. It's a data science governance tool. It's a data science catalog, because whatever people are doing with the data, for me, is a data science. Okay, enough about myself. Oh, by the way, yeah, I created the Spark notebook for who use Spark. Nobody use Spark, so you don't give a shit. All right, about what I did in the past, it's not a problem. Okay, so the topics for today, some thoughts about data science. We're in the data science meetup. I don't think it's going to be disruptive. I'm going to give some beautiful enlightenments there. However, it's a nice introduction about data science governance, of course, how we can achieve it somehow, and of course, a bit about GDPR accountability and transparency principles, although they have been introduced in a very beautiful manner in the two previous talks. So I'm not going to spend too much time on that. But however, I will take these principles and say, okay, how the heck can I use these things if we implement them correctly in order to turn them into added value for my business? All right? So are you agree with this skill? Do you like it so far? Okay. You cannot say no, of course, right? some thoughts on data science. I'm going to go quick on that one. Machine learning. If you think about data science is all about machine learning, you're probably wrong. You probably know that now, I guess, right? Machine learning is a whole chap. He is there for more than 50 years now. It's almost 70 years. He has an AI venture, in 70s. Then we discovered backpropagation, and oh yes, we can do things with machine learning and stuff. Then in the 90s, it became pretty famous. Then people started understanding what can do machine learning. They started integrating them into software at some point in the 90s. Then deep learning in 2000s was already involved into and introduced into computer science, softwares in 2000s. Although if you look at the blogs and whatsoever, you think that the deep learning dates from 2014 or maybe 15. No, it's an old chap as well. And afterwards, machine learning or whatsoever, whatever you call it, has gained a lot of publicity in 2010s, right? 2010s, although it was very old and it has been used in software before. So there must be a root cause. As data scientists, we always like to find a root cause, even though we're never sure if it's a root cause or not. But anyway, let's try to figure that out. So machine learning, it cannot be only data science. Data science is machine learning plus at least engineering, right? Why? I mean, if you look at who has coined this data science or data scientist word, it was D.G. Patel. Do you know who is D.G. Patel? Right? D.G. Patel, who used to be the CDO of the United States of America. Right? So this guy coined the term, right? Of course, he's not anymore the CDO of USA, but he used to be at this position. He said, okay, now we are going to talk about data science. It's not about machine learning or whatever. We're going to do science on data. Okay, fine. But it happens in 2008. 2008 when we had a great publicity, but when we have used advanced machine learning algorithms into softwares. And when we really liked to use this kind of technologies and power into softwares in order to make more money or more market revenues or whatsoever. Okay, so that means that at some point we had to use, to add engineering in the mix in order to make it buzz. Because data science community is like this, computer science is like that, right? So if you add machine learning into the data engineering or the engineering market, then you have a buzz. Otherwise, it's just a nice group of people chit-chatting with beers. That's it. Because it's mostly university back then, so of course it was beer. And by the way, in 2008, this is also where distributed computing started to be something that most of the companies, big companies were looking at, because Google was there for quite some time and they make a lot of money with this, right? They said, yeah, okay, so it's time to look at this. Of course, I'm not talking about legacy systems or legacy actors in the environment, but new unicorns were talking about distributed computing. And distributed computing is a lot of engineering, of course. It's a nice thing, but it comes with many, many, many problems, right? Okay, so we have to add engineering, but it cannot be only machine learning plus machine learning plus engineering. You have to add something into the mix in order to reach something that you can call data science. And this is where GDPR comes as a pain, because you have to add experimentation. What's very interesting with science is that you want to discover things. Otherwise, you don't do data, you don't do science. You're just a practitioner, right? So if you want to add science, then you have to experiment. You have to find. You have to disrupt models. You have to be able to create, right? But how can you really create if you have to say beforehand what you're going to do, right? That's a tough one. That's a really tough one. But so we have to do experimentation in data science. So we have to take data, we have to mingle them, we have to clean them, join them, cross them, or whatsoever. And that's our job normally. We want to do this because this is how we can disrupt a market. So now what happens is that we have computing frameworks, distributed computing frameworks. We have a ton of data available. That means that we can try to do whatever we think might be relevant. Might be, because of course we have so much data that at some point we can randomly find something, right? that is randomly correct at some point in time. That's a problem with big data, of course, but obviously I'm not, teaching anything here. But anyway, discovering new insight and potentially new businesses is like, you know, the nirvana for the last decade, right? So everybody thinks that with data, we're going to disrupt our business and we're going to find new insights that allow us to, grow more rapidly or to eagerly eat the whole market. That's how they think about data. This is why they call it a new gold or a new oil or whatsoever. There is really money involved in there, right? Oil, gold is all about money, business. That's sad that it's like that, because generally they have the money and they provide them to IT guys that can do things with the systems they have in mind. So recap quickly: math, engineering, creativity. That means that for me, everything that you do on data, whatever it is data science. It's part of the picture, right? Because if you don't have any data in your database, how the heck can you do data science? How the heck can you do machine learning? If your data is all crappy and there is no one that can clean it a little bit because he knows the data before you can apply some learning on it, how can you do anything with that? Because you're going to spend more time in cleaning data than anything else. And generally, when we think about business intelligence, there is a kind of pre-processing which is involved in order to gain time. If you don't believe me, just read this paper. Right? This paper is hidden technical depth in machine learning systems. And guess who wrote it? Just a guess. Who? You? No. I would have loved to. I discovered it last year because it has been issued last year, and I was thinking about this idea already 5 years ago. But this is Google, man. Google wrote this because they discovered that their system were rotting. The learning were rotting in production. And they're Google. It's probably the one company you think about when you are wondering which company is making money out of data. Google. Google wrote this paper explaining, man, ML code is right there, and everything around it can screw it. Everything around it, configuration, data collection, feature extraction, analysis tool, everything around it can screw it because this is just a model. It makes a lot of assumptions. All right? And if you still don't believe me, by the way, just check out this 3-minute lecture into the Google Machine Learning Crash Course. It's a very nice course, I would say. Even if you are proficient with machine learning, just cover it because it has very nice say in there that we recommend. And there is this nice video where, by the way, there is this picture coming back there. And if you still don't believe me, there is this 14 minutes lecture a little bit further in the course where there is a sentence that I love. It's feature management, input data features determine ML system behavior. It's correct, right? But if you need to check that, generally, as I will come back to that later, we have to write unit tests when you're a software engineer. But how the heck can we write unit tests for data? That's a tough one. That's really tough because your machine learning model can go nuts because actually your assumptions on the data are wrong at some point. They may become true again, but at a certain point in time, they were wrong. But if you're a trading system, you can lose a ton of money at that point in time. Okay, so data science, governance, what? So now that I scared you with a few things, let's talk about data science governance, the initial topic that I wanted to talk about. Beforehand, although everybody knows what is a data pipeline, how do you think about it? Data in, data out? Okay, I don't think like that. I think like data in, maze, and many outputs, right? So this is a pipeline. This data pipeline is just a sequence on different segments of computations from different units, maybe different companies, right? Right? So actually you create a pipeline, you're a developer or you're a data scientist, you create your own pipeline and you think it's going to be great and even you monitor it, right? You deploy in a production, but at some point somebody is interleaving with your pipeline because it takes your data out, it creates a new model, right? So this is not impacting you. But what if his assumption on the data that you have created during your pipeline is different at some point, that your changes that you will apply 2 months further? You have a pipeline, you don't know that this guy is using part of your data, you change your model because your assumptions are differing from the beginning. Then you change your transformation, you change your, I don't know, your PCA, you take more variation, you take less because it takes too much time to compute and you don't need to have this accuracy. You take less singular value, right? That screwed the other guy because the other guy was assuming that he will have so much variation in his data set. And guess what? He will never know. So data pipeline, you have to think about it like it's a maze. You have data in, transformation, data out. However, the data out, why do you compute things on data? Why do you do that? It's in order to take decisions at some point. You don't do it for the beauty of it, right? Generally, you have a question, you answer the question. And based on this answer, the result, it's very likely that someone will take a decision. I always like this, you know, this marketing or whatever, portfolio or whatever. You have a person that is showing a pie chart like this, or your line chart that goes up or down. I mean, okay, great. I mean, it looks like the business is going well, but who is validating the data beforehand? And who is validating that the processes are still accurate? And I don't know if I can show it. Maybe it's going to be broadcasted, but I can show this article. I will send the link later. But guess what? Actually, the people that are showing pie chart or line chart, I mean, the people in the room, you know, this oval desk or table, they say, okay, but is that true? Can I really use this information to take decision on my multi-billion business? You're gonna validate your thing, right? And generally it goes through manual human validation processes. This is how it relates to. So recommended article is not too long, but it gives like a problem, because if we are in the area where data science is the hot topic, it's the new goal or whatever, then we have to figure out how the business can believe in us. All right, so big decision, and as I said, the pipeline is a cut and wide into Toledo whatsoever. So as a data scientist, how not to be anxious? Man, I mean, people are really taking decisions with my models. Man, I can start to be anxious, as I used to be in the past. So, okay, what are the sources of anxiety? So now let's try to pinpoint the problems, maybe. I already said it, right? So, what if one of the data used in the process, I didn't say that one, is this one that I mentioned before. This one is more, I have assumption on my data, right? Is what we call stability, right? We have to ensure that your data is stable, right? You make assumptions, right? And if you are not doing the data cleaning from the beginning, right, you have to make assumptions, right? Or you have to remove what we call what? Outliers, based on assumptions anyway, right? Most of the time. So we are making assumptions, but what if after, at some point, right, we are making assumptions that are wrong because the data patterns are changing. So the outliers are not outliers anymore, right? That's not something hard to solve, but you have to solve it, right? I'm not saying that they're, oh, wow, I didn't think about it. No, it's obvious, right? But you have to think about it when you deploy something in production. That's it. So what if one of the tools before, you know, you have this pipeline and then you take some data, you don't even know from where it comes from, but you have your notebook where you do some validations, descriptive statistics, you make all the nice check that you can do on the data, you say, okay, this one is good for me, I can use it, right? And the guy before, on the other hand, at some point say, my model is going nuts, so I'm going to change my model. So I'm going to change, as I said, maybe the result of my PCA, and then boom, the other model goes nuts because it doesn't have any more validation. The other goes right because now it has maybe an online learning tool that has to answer within 10 seconds, right? It has to reduce the amount of data, so it reduces the PCA, so it's okay. because it doesn't have to have a high accuracy, but the other guy has a strong constraint on accuracy, by the way. So that's the kind of anxiety that you can have when you deploy something in production. And of course, that's where feedback is very important. How can we detect that the insights are deviating from the truth, from the reality? How can we detect that? Think about it. I used to work also in medical. That's the kind of thing that you have to know, right? And you know, reducing the false negative is not always the ideal solution anyway. Okay, so what do we do when we're anxious? When we develop something, we debug. Because we have found the problem. So, there is a problem, so let's debug it. Okay, so we need to have a way to debug it. As an engineer, you're going to write tests, unique functional integration tests, acceptance tests, whatever tests, right? However, as the Google guy said, right, how do we do when the data comes from the problems? Are we going to generate all the different patterns that can happen in the world? That's unlikely to be feasible. So generate all cases is very hard. And by the way, when you are dealing with problems with data, generally in order to debug it, you need to have which data? Which data do we need? The data which is in production. Right? And the answer to, hey, can I get data in production in order to make my tests? 90% of the time is going to be no, you can't. Right? Because there are so many regulations. I don't know how many of you are working in banks, insurance, or big institutions like that with the high regulations? 1, 2, 3, yeah, a few of you. Maybe some are not raising their hands because they're shy, but over there, yeah, I mean, if you ask for the person data, the answer is going to be no, right? So then, how can you debug something that you don't have access to? Because the problem is the data. And this is where data science governance can come in place, right? So let's take a very quick definition in 2 sentences, a very quick definition of data governance. Who knows about data governance already? One, a few, right? So master data management and these things, so ring some bells, right? So the very interesting thing in data governance is that you want to control the data meets precise standards. That's the first thing. But this involves monitoring against production data. You monitor the production data. If you think about data science governance, provided that data science is any activities on data, right? What do you want to control with governance is the data activity, your model, your transformation, your cleaning, your anonymization process. I like that one in GDPR. Yeah, we have to anonymize it. Really? How do you measure it? How do you measure that with some piece of data? There is no way you can reconnect the data to an individual. It's pretty tough. And they are masters in that. And the masters are in the defense government on each country in the world. So how can you validate that your anonymization is going to go very, very well for all the different processes? Again, is an anonymization conditioned to the kind of processes you will do as well on them? Because if you don't do a magnificent transformation of the data or models, it's likely that the original data may actually be anonymized already because you don't need all the data, or you don't use all the data, for instance. So, so the data activity meets precise standards, and also it involves monitoring against production data activity. So you want to monitor how accurate is my model. What are the patterns in and out? What are the mean, average, quantile of my data in? And what are these parameters as an output of my processes? So that's the kind of thing you want to monitor because they are a proxy for your quality, for the quality of your data or your process. Okay? And this kind of information will give you enough information to be able to debug. But what kind of information are we talking about? The technologies that you have used. Did you use TensorFlow or scikit-learn to run your linear regression? I mean, you might think that it's stupid to have that, but At some point, if you learn that you have a problem in the linear regression implementation of scikit-learn, you have to know where the heck this implementation has been used, right? So technologies, users, who did what, right? Who is responsible of this kind of knowledge internally? Who is able to give good prediction for anti-churn problems, right? The system that has been used. I like this one as well, because everybody knows about Docker. Docker is a genius. I mean, Kubernetes is just the sibling and whatever. But actually, containers, you provide resources at configuration time, right? And when you have a machine learning model, right, which has to provide insight every 2 seconds, and at some point, someone makes a mistake and deploys the new container with 1 gigs instead of 2 gigs, right? Then, again, we go back to the initial picture with ML code is like this, and you have this holistic problem around it. Actually, changing the memory of the container is actually impacting your machine learning process. So you probably have more and more anxiety raising in you, but okay, I mean, that's, sorry, but it's like unit testing in engineering like 10 years ago when we introduced Agile, right? In order to try to minimize the problem. And by the way, afterwards, you have to collect, of course, information about the data and the processes themselves. Like, what is the lineage? What did we do with the data? How did we join the data? Did we, I don't know, filter the data whatsoever? Think about that one. We have talked a lot about consent, right? We have to gather consent about, you know, from the individuals, data subjects, as we call it, right? We collect this information. It's very accurate, very updated. But what if we don't use it? We have the consent, but we never mask the data with the consent. That's a tough one as well, right? Because actually, consent is nothing but just a mask on the data, right? And the mask can be either removing the data or filtering the data, depending on which situation you are. And of course, the time to live and this regulation is adding a lot of constraint on the amount of data you can keep. But still, if it's a new data and there is a consent, you still need to mask it. So governing data science is really about trying to know who did what on which data and where it has been done. What is the impact on the process in the global system? And what are the performance metrics of the processes? These are 3 questions you really want to answer. And guess what? With data science governance, you will get data governance for free. You get it for free because actually you have all the information in order to control also the data, because data are nothing but side effects. Data doesn't exist by themselves. We create them. There is a process at some point that creates numerical data, right? I cannot take data like this, right? That's what I mean by that. There is always something. There is a sensor, there is a collector, there is anything in place created by human that will collect data. So there is a process somewhere which is responsible to get this information. So data is just a side effect of a process, an execution. So if you have this, actually what you get for free is a continuous integration system for data science. Because if you collect metrics about your processes quality, if you have for free metrics about the data themselves, and it runs in production, because actually you're not impacting the production because you're just fetching some metadata while the processes are running, then you have this continuous integration system for data science that allow you to debug your processes in production. Because if you have the information about the patterns, right? Information about the patterns is really like music, right? So you have an harmonic, then you sample it, and then you will have a good accuracy for the music, right? And having a pattern is just sampling the quantiles, for instance. Then you have a good information about how the data is looking like. Yeah, what is the shape of the data? So that's the kind of information. Then, if there is a problem with the model that goes down, for instance, let's say your I don't know, your next best action is not performing very well, right? So every time you provide a insight about the next best action NBA for a user, it goes nuts. Right? It doesn't perform very well after the feedback. But at this stage, if you know, first you know that it doesn't give a good result because you have the metrics. Second, you have enough information to know if it's a model, if it's the data, or if it's the system around it which is screwing the model. In the past, I spent weeks in front of my model that is like 10 lines or maybe 50 lines, right? Like this. What the fuck is going on with my model? I don't understand, right? It's so correct. I take my sample data or my anonymized data whatsoever, I still have a good solution. So there is something that must go wrong there. And then you have to chase people in order to, you know, behind the curtains, okay, give me a bit of data, so otherwise I cannot do my job, and my boss is sitting on me right now. So, and that's the kind of thing that you shouldn't be doing, but it's always like that. And at some points, people are helpful. So you need to be able to debug pipelines independently of the technology that have been used. And anyway, wherever the data has been processed, you need to have information about how it has been processed so you can understand if yes or no the data is good for you. You have to decide that at some point. Because in the case where the fictive case that I was taking, right, you have the pipeline PCA. If you at some point you detect that, right, then what you have to do is to run your own PCA. It's not a hard problem to fix. Again, when you debug something, generally the solution is pretty simple, right? But you have to understand what is the problem. And that's the current problem that we are facing with this anxiety. How we can achieve it is going to be tough. The challenges are that we have so many tools nowadays that are using data. And by the way, we have new tools every day coming, you know, like, I have this library on Spark, I have this library on Flink, I have this library on whatever. And then there is this new tools coming up, and then a lot of people are very enthusiastic about them, so they try to introduce them. So that's the kind of thing you have to, you know, manage. And also, obviously, because data science is a lot about experimentation, the number of processes is growing like crazy. You have probably encountered this, right? This data lab or data science hub or data whatever teams in big enterprise. These guys are there normally to, I hate this word, but to play with the data, right? But playing with the data, I mean, it's like kids, right? I have 2 kids. I know that when they play with something, it's likely that they will break it, right? And it's the same thing for us. I mean, we are trying things. At some point, we reach a point that we shouldn't have had to reach normally. So that's the kind of thing that we have to worry about as well. And by the way, we have to take care about the legacy, because it's not as simple as saying, okay, I'm going to, you know, just to take care of the new Python stuff that we are doing right now, and I don't give a shit about mainframes or, you know, Excel sheets, you know, floating all over the place. I will just manage this, but it's not enough because you don't have the holistic picture then. Then you cannot really know if the data is good. You don't know how to debug your whole process. You have to have the full picture in order to have it. So getting the data is going to be hard, right? The thing is that you have normally to, you know, to address each tool in the enterprise in order to do it, and it's a tough problem. It's a hardcore process. But again, I mean, what kind of things can you leverage based on this information? By the way, when we talk about GDPR, I don't know if it has been mentioned. Maybe I didn't hear it, but there is this notion of data flow, right? This notion of data flow, knowing how the data comes in and goes out. You can take a high-level view, and you can have, you know, just the business aspect, but you can drill down and say, okay, how really the data have been used and for what purpose? So if you know that the data in table customer, right, and the data in table, let's say transaction, and the data in the table, I don't know, Twitter, has been used in order to do anti-churn, right? And you know how the data have been used internally. You have this notion of lineage. You have it into the system. You know what? Actually, you have all the knowledge embedded into your system. Because at some point, if the guy who created it or the team that created the system leaves, right, the knowledge on how the data have been processed, for what purpose is remaining. It's sustaining in the enterprise. Right? So this is the kind of information we have. So the information that we have has to be connected. So it becomes a huge graph, and I'm glad that nowadays graph is gaining attention from the market and from the technology point of view, because graph are so important. Yeah, when I did math, I did a lot of graph theory. That's why, you know, I like that. But again, it's a very intuitive way to represent data and, of course, dependencies. and of course to discover insights that are computation intensive in regular relational views like data frames or such. So connecting the data gives a full map on the dependencies and distributions. And this is where it becomes very interesting, that we have collected the data, you have connected them, now we can use them. This is really where you can have fun. Why? Because now that we have this data, we can run impact analysis. That's really governance. You can do dependency analysis, of course. That's also governance. Pipeline optimization. Do you know the story about Toyota and Ford, right? So you know that at some point they screw Ford because they were able to understand the process so well that they could optimize them. And they could produce faster at cheaper costs cars. And Ford was like, how the heck can they do that? Because they know the system, right? They know exactly how the different things are connected, how long it takes for this piece to go from there to that part and then to be processed. This is the kind of information they had to collect, and it's very hard because, of course, producing a car is huge, is long. So they had, involved a lot of money. They created a budget in order to have all the different trackers, and most of them were visual, right? So you had a lot of crappy data because most of them were visual. So it's like you have many sensors. But they did that anyway. They screw the market. So that's the kind of thing you can do now, because you have this maze that I was talking about, but this maze is known now. You know how the data are connected. You know the flows, you know the pipes, you know exactly everything over there. So now you can optimize. And by the way, your system can optimize by itself normally. That's what NPM was for Toyota, right? So that's the kind of algorithm they could use with that. And by the way, when you know that this lineage is doing something like a next best action, I hate this word, NBA. If there is a new person coming into the enterprise and the boss says, okay, you have to do NBA, right? But there is no article in ArcSIF about how to create an NBA model, right? It's something which is related to the business where you're working in, right? This is because, of course, you have many companies and each company is holding a part of the market, right? They have a specific data set. Then the way you will be doing NBA will be also really dependent on the bear market you're in. So that means that if this new person comes in, it will, leveraging the knowledge that has been collected into the enterprise will allow him to know what kind of data. I'm not saying that this data has to be used, but what kind of data has been successful in the past in the enterprise in order to create accurate NBA, right? And which one weren't as well. And what kind of algorithm were used in order to run this kind of model in an accurate manner as well. This kind of knowledge can be automatically shared. Now you think, okay, what the heck has it to be linked one with another to GDPR? So GDPR, I'm not going to talk a lot about it because it has been well covered, but I'm going to at least reintroduce accountability principle, which is really about being able to demonstrate that you know what's going on data, if I can put it like this, right? But the thing is that, which is very interesting, is that you have to implement appropriate technical. So already technical. And there is a notion of internal audits. So technical and audits, two things that fits very well, right? Generally, audits are really Excel sheet or whatever, and then you have questionnaires, takes time, and it's a snapshot. So an audit is a snapshot of the company. It's not really time, right? So you have to demonstrate your accountability, and they foster the usage of technical solutions and measures internally. But you have to know the processing activities. Transparency, this is all about, not all about, but at least it has to deal with this catalog of processes, this registry of processes. Right? You have to show that you are transparent, you know what you do, how it has been done, what is the goal of taking this data in the enterprise. We take this data in order to do anti-fraud, and we also use it in order to do, market segmentations. Okay, so that's the kind of thing you have to be able to provide into this catalog registry. So for who is in a big enterprise, how many processes you think you have? How many? Hundreds, tens, hundreds, thousands, Yeah, companies that I've met was reaching million, right? Big enterprise, they have so many things. I mean, they have multi-countries, they have multi-ways to do things. They reach millions. Go ahead. So you have reached 250 employees, of course. Go ahead. Go ahead and, you know, create the whole registry. It's going to be tough, and maintain it. And it's okay. I mean, at some point you will have to do it. There is this assessment to be run. All right. But when you're a data scientist, man, I mean, every time I'm going to use data, I'm going to document it. Or every time I want to do something with the data, I have to beforehand explain exactly what kind of data I need in order to reach the accuracy that I want. I mean, if it would be possible, there is no data science anymore. I mean, we have solved it, right? So, I mean, actually, it's very tough for data scientists. I'm not talking about general purpose processing, right? I'm really talking about disruptive processes, right? So, where you don't even know where you're going to start from. So, okay, so please make a new user segmentation. Okay, you know there are 2 or 3 data sets, but if you want to really disrupt the market, it's going to be tough by using only the same data. Or the previous guy before you were morons, because actually if the business is running for 40 years, it's likely that the data has been improved and probably overfit for 20 years already. So the accountability principles, I mean, data science governance can come with a piece of the solution. I'm saying that it's going to solve the whole thing, but at least it comes with a piece of information, because you have to connect activities, data flows. You have to connect activities so you know exactly how the flow is going. And by the way, it can help you building and maintaining this catalog of processes when you're running your analysis. So take a notebook. Who use notebooks here? Notebooks. Okay. So why do we use notebooks? Why not? Because if you use notebook, you can do pretty much whatever you like, right? And you can run it, you can change your model every 2 seconds if you like, you change your hyperparameters, you change your preparation data, you change everything. I take my vectorizer, right? I put in there, I don't know, city, and then I put something like latitude and longitude, because initially, you know, I thought that it would be enough, and then I'm going to put the name in it. I just add rows into my features into my model. I mean, who prevents me to do it, right? I'm not saying that we should be prevented to do it, because probably the business will, be improved by your discoveries. But at least you need to have a process that allows you to do it within GDPR constraints. Because otherwise your anxiety will be so high that you probably not want to add the features as you like. So this dynamic processes is very a problem when it boils down to demonstrate accountability. By the end of the day, it would be very hard for me to say exactly what kind of test I did. And by the way, where are the data that I improved? Because data lake is very funny. You have a notebook, then you can generate data sets whatever you like in a data lake, right? But what if you don't delete them? And what if someone else is using them because he discovered it? That's why we say data science is the Wild West, by the way. You have heard it, right? It's the Wild West. So Wild West is all about outlaws, right? And GDPR is allowed, kind of. Transparency. Data science governance can come also with a piece of information, a piece of solution. Because actually, when you do data science governance, you can detect what kind of goals that were pursued and how it has been achieved, right? If at some point, right, you have a model where your lineage is showing that you are intentionally removing, all the persons with a height above 1.50 meters, I don't know, right? That's discrimination that you cannot really do, right? And actually, guess what? You didn't on the propose. That's the fracking random forest that did it for you, right? Because this is how it works. It just creates cubes into the area, and then it removes this kind of information out of the process, because this is how you gain accuracy and you optimize your revenue, for instance, right? But if you are able to transparently explain your model, and an ethical person falls on that, they say, this is borderline. Of course, you didn't do it on purpose, but it's still there. right? It's still there. Now think about deep learning now. How the heck do you demonstrate transparency with deep learning? That's why this kind of processes, I can have some validation over there, but deep learning and stuff like that, there are areas where you just can't use it, right? Risk management, ledging, and these things where you are in front of you someone who is asking for money, and the process says no, right? And the person says, why? I don't know. Because this process, which is a lot of randomness, said at some point, no, that's not possible anymore. So there are specific areas where you just can't. So, and in TensorFlow, it takes me like, I don't know, 10 minutes to run a deep learning algorithm and then ship my result. So transparency, I mean, this is a multi-billion business if someone can demonstrate transparency of all the different models that are existing, right? And I guess what? A lot of universities are working on that. Okay. I still have quite some material, but I will distribute the slides anyway. Now, how can you leverage GDPR? Because that's the international purpose of this talk, right? How can we use GDPR family in order to disrupt the business? But what are business KPIs but data? Right. In a way, if you're tracking the data all along and the KPIs which are determining if your business is going well or wrong, right? And if you are able to debug your process based on information you have, you might be able to debug why your business is going nuts. Because they are just data. Again, people are making decisions upon data. Let's flip that, business to data. So the way we really think about, okay, I'm going to use the data, you want to change your business in order to match data, right? This is really how we think initially. So I have the data, I'm going to optimize, I'm going to have a good accuracy, I'm going to have a good feedback and so forth. But what if you are able to understand how the system works, right? How a data pattern at the input is changing the patterns in intermediate data sets and in the KPIs, right? You can think about, okay, in order to change this KPI up like this, I have to change the patterns like that, right? But what are these patterns? Maybe social interaction. Maybe it's a reaction to marketing sentences. Maybe it's a different kind of data that you are collecting from the people based on action that you also taking based on you're taking on your customers. So at some point you should be able to change the data in order to have better KPIs. And actually this is how disruptions work, right? If I have a smartphone at some point in my pocket because someone at some point says people will need that, right? Because it didn't exist before. But how the people are using their phones? How people are they using their laptop? Why do they use them? It's a lot about communication and games. Okay. Probably they want to bring it with them. Game Boy is a large market. Why don't we just combine everything? So if we want to have a business with smartphones, what should we have in there in order to get it? It's really product management things, but it's really about changing the data in order to get the result that you are willing. So of course, what time is it? I don't know how long I'm talking. So almost 15 minutes. So I'm going to go fast again. So this slide will be distributed. So at Kensu, that's my startup that I started a while ago already. Of course, we are taking this idea, we're implementing it, right? For many parts, and we try to go further. So you will have, again, we will have the slides, but what we really do is trying to get data science on data science, right? Trying to have all this information and trying to run data science on them. So how can we get insight of insights? How can we give recommendation about models? How can we give recommendation about data? How can we give this kind of information directly to the data scientists, but also based on information that we can get to DPOs, CDOs, and even authority. So by collecting, as I said, information, so I give pretty much a secret sauce here, but it's a tough work to do, of course. So, and based on information we can have, I can, in one click, I take one data, right? I say, give me the data flow, right? And it produces this kind of resume where you have all the data that have been involved, what are the different kind of data, categories of data that have been involved, how the different columns have been used, right? And in red you will have, for instance, the sensitive or privacy information that has been used. It has been kind of just transferred, there is no join here. And then you will have also the user that participated to that, and then even the executions, what tool at what time did do that. Why do we want this? In order to debug, right? Because at some point, if this is breaking the rule of GDPR, right? First you have to figure that out. There is a DPIA thing. DPIA thing will be, much more facilitated based information which is over there. And at some point you can ask, okay, Penny Parker. So remember, Penny Parker. Why did we use this data? What happens if we just remove this red line? What happens? I mean, that's what it will be, but I don't know, right? Especially, I might know what will be the impact on my own output, but I don't know what will be the impact of the other outputs, that are using my own data. So that's the kind of thing that you can directly access based on the information that we have over there. And how it works, it's rather simple. So we have many collectors, but we just have an API, and most of the tools are just sending information to the API. Like, here is a data set, here is a schema, here is a lineage, here are the dependencies, etc., etc. And there are some tools like Spark, for instance, where you just have to do spark.track, and then the tool is doing everything for you. Why? And this is why I'm using Spark since 2011 now, because it's a DAG, it's a graph. So based on the graph, you have all the information you need, because it's right there. And the way you build the DAG, so I'm not going to go in details, but because it wants to be asynchronous and so on, but it has information, so we can extract all information from there, like white curve transformation. Did we filter? So it's nice because if you filter, then you know if you have applied the constant. Did you join? Did you join the data? Did you aggregate data, and so on and so forth. Also, you can gather statistics, quantile, summary statistics, and so forth. You can also detect automatically the different machine learning models that have been run, trained, with which hyperparameters, and what are the different metrics for your model, right? So, in the course, the Google course, there is also this nice lecture where there's no notebook, sorry. So Google has this Colab notebook, so you can run it in Drive, for instance, worth trying, so you don't have to install Jupyter, right? And at some point they say, well, we are running here a test, then a second test, a third test, but generally you have forgot what were the metrics from the first and second one, so you can even any more tests or back test them. So they said, yeah, you should be tracking on the side what are the metrics. Actually, no, you should have a system that does it for you. That's it. So the performance of the model are published as well automatically. And of course, as I said, so we are doing a data science. So what we do is that it doesn't really matter if it's dev or prod, right? Actually, the system is pretty much behaving the same way. If you read cold data or hot data, what you're going to use to pick parameters or use parameters in one way, you're going to train, you're going to run your model, and actually what you want to have is this output to be automatically published to a system. And what this system connecting is the data flow, right? Data, prepare data, intimate data sets, parameters, and the model, register the parameters, and then of course compute and perform parameters and metrics over there, because the process is not intrinsically very different from the other. So then automatically you can get that, and actually what is the lineage, which process did what is the linear model, in this case it's a linear model that has been run, what were the last things, and how the system behaved for the last different runs. So you can even work in notebooks. I said, why not, right? Why not? Because it's hard to track, so let's have a kind of tracker, a monitor, and you get the data, then you're good. So if there's something wrong, our system is going to tell you, actually, you're using this data for the first time. Oh, actually, you were already using this data, but this column, which is containing privacy information, this is the first time you access it in this specific goal, right? So these are elements that are very useful for the manager, yourself, and the DPO in order to qualify activities. So it works from different environments. I just provided, of course, notebooks. This is a summary of what I've just said. This is just something for you after when you will get the slides. So we give training, but especially in Roma and in Milan soon. And about Spark and machine learning and data science. And this is it. This is it. Unless you want to talk, but it's like, what? 9:30. My contact details over there, just shout out, contact me, or I don't know if there's still time to get a drink, probably not. But I'm happy to talk anyway. I don't know if there is time for questions, or if there are questions, by the way. No? All good? Good. Thanks, everyone.